Hello everyone, welcome back to the 5 Minute Tech channel. Today we will be talking about LangChain and its ecosystem and how we have to move away from the mindset of creating the toy chatbots and embrace the LangChain ecosystem for our enterprise. We will be diving deep into the multi-agent architecture with different tech stack which involves Python, .NET and Java. I'll be illustrating the architecture for each of these ecosystems and the languages involved. So let's get started. So the problem with basic LLM is it has no state. They forget the previous step and complex tasks, and the single point of failure is present in those LLMs, and it can't be designed for a production system. One model trying to do the research, coding and creative writing simultaneously will not work in the current scheme of things. We also use it as a black box. When it hallucinates, we don't know exactly why and know how it will go and self-correct. We need to give it repetitive prompts to align its path, and then there is a no proper way of deploying such a LLM based solution. Jupyter notebook or a chat sequence isn't enough in a form of a microservice which you can plug and play in the production. So what are the four pillars of the LangChain ecosystem which tries to solve the problem of a standalone LLM model? Is the LangChain, which is the brain. It has the core abstraction for models, prompts and tools like vector search, web APIs. The LangGraph, which is the orchestrator. It is a stateful cyclic routing and manages loops, human in the loop, and also the agent memory. The third one is the LangSmith, which is the observer, wherein we can do a deep telemetry. It has the traces, execution flows, token usage, latency and tool inputs. And then final is the LangServe, which is the gateway, which turns the chain and graphs into the production REST APIs, which we can use along with native framework. Now multi-model strategy is what we are looking at. We will not work with single LLM, but we look at a local AI ecosystem, which we will be doing in our setup using Docker. We'll use Olama and run the models, that is for Qwen and Mistral. It will be 100% private, zero cost infrastructure. Supervisor agent evaluates the request and routes it. Then the analytical agent, which will be our Qwen model 7B, specializes for reasoning tool usage, retrieves the data from the local vector database, and the creative agent, which we use as a Mistral AI, specializes for natural language generation, tone and formatting. So this will be our implementation which we will go through, and there could be many manifestation of this kind of implementation. So native standard is Python architecture, in which we have the Python as the base stack along with LangChain, LangGraph, LangSmith and also LangServe. The deployment is through Fast API. It replaces LangServe for enterprise scale, so we generally use Fast API. Then the state management will be typedict for mutual graph state, and the pros for this design is the first class support, fastest updates, native LangGraph integration. And this is the basic Python code where we define the graph. The syntax highlights the orchestration code of the in Python, and its basic simple representation on how it will actually work, but there will be a bigger project which I will show you, which has all the layers involved. Here we define the state graph, add our Qwen and Mistral agent as nodes, and then create conditional edges. Now this is this compile app is what we expose via Fast API. This is one snapshot where you can see we are adding the different models and trying to get the responses. And this is the broader architecture wherein we have the client environment, that is a web browser or user interacting through user prompts, to the Python multi-agent AI agency is what we'll be working on. And the LangChain ecosystem has your Fast API, that is the REST API, along with the graph supervisor node. What does that do is it interacts with LangGraph workflow orchestration, stateful cyclic graph, and then the mutable agent states are there, analytical agent, creative agent, and then it will send its query, that is the RAG query, to the vector search tool, that is the LangChain tool. Along with that, it will also query the models, that is through Llama. While LangChain providers, it will have analytical reasoning model for Quen, and also will have the creating and drafting model for Mistral. Now all this will be running over the Llama server instance, and this will all be containerized and present in the Docker. And then it will also have its own telemetry in terms of Langsmith. I did mention about the cloud dashboard, but we'll try to have it in our local setup itself, and will provide the comprehensive token traces and how the token usage is happening, and then also the latency with the telemetry in the telemetry format. So this is what we will be trying to implement to see how it goes with using the Python ecosystem. Now next is the Java architecture, which is an enterprise giant which has a lot of applications in the enterprise framework, which and in this setup we will be having the Java ecosystem. We will have the frameworks involved, the data record, and the telemetry. The stack will be our Java and the LangChain 4J and LangGraph 4J. We will be deploying it, deployment wise we'll be using Spring Boot, REST controllers, and we will have a Flux. State management will be through immutable Java record classes, and observability will be using OpenTelemetry native integrated. So this will be our Java implementation which will be going through. The Java basic Java code, wherein the LangChain 4J delivers our clean architecture which for our Java developers. Instead of scripting, we define AI services as interfaces, and the tools aren't complex wrappers. They are just standard Java methods annotated with add tool, and Spring Boot handles the dependency injection automatically. And this is a basic code which we'll be having in our broader application, which we'll be working on in the subsequent video. And this is the entire architecture of our Java based multi-agent AI system. It will have, as usual, the client environment interacting with Spring Boot REST API and microservices, and the supervisor agent will interact with LangGraph 4J workflow orchestration through the analytical agent and creative agent, and which will involve our Quen and the Mistral models along with our vector database, which will be queried for the RAG using the Lang4j tool. And this will all be running on Llama along with your containerization, and the basic OpenTelemetry will be in place, which will do the work as a collector, and will have the observability backend. So this will be our implementation using the Java setup. Next is the .NET. In the .NET system, we will have the .NET Core 8. I will think we will be doing with 9, but we'll see if we can do it in 8 using the LangChain.net, and the deployment will be in your ASP.NET Core minimal APIs. State management will be strongly typed C# POCOs, which we'll be using. Observability will be through tryagi.langsmith SDK and the .NET Logger. .NET Core multimodal dependency injection will be used. We use the keyed service to inject Quen for analytical task and Mistral for creative task, and then we expose our AI workflow using the minimal API. Now below are the 3 kinds of code to expose the multi-agent system to the web, which will be integrating in our application, which we will be using .NET for. And this is the multi-agent architecture for the .NET ecosystem, wherein we will have the LangChain extension for dependency injection, minimal API endpoint, supervisor agent interacting with the LangChain.net orchestration layer with the 2 models which we have, which is Quen and Mistral. Along with that, we will be dockerizing this whole implementation, and the telemetry will be on the Langsmith, which is the tryagi.langsmith SDK. So this will be our .NET implementation, which we'll be doing in our subsequent videos. Now to complete the ecosystem cheat sheet, the LangChain ecosystem is not just a Python library. It is a universal design pattern wherein you are using Python, Java, also C#, and the concept of tool, cyclic graph, state, and observability, which remains exactly the same as you see in the Python library. So the features like core AI logic we will be doing in .NET as well as we do in the Python and Java. using LangChain, LangChain 4j and LangChain.net. And the alternative would be semantic kernel, which is more native for .NET, but we will try to see how we can exploit LangChain.net. Orchestration will be with the LangGraph in Python, LangGraph 4j in Java, and our AutoGen in .NET. Deployment for Python or the APIs will be through Fast API. Java we will have Spring Boot, and ASP.NET core minimal APIs in our .NET. Observability, as we saw, for Python it was Langsmith, for Java it was OpenTelemetry, and for our .NET we will be using tryagi.langsmith. So that is the basic structure of our system, how we can design our LangChain ecosystem in different tech stacks across different languages. Now in the subsequent videos I'll be going through each of these languages, starting with Python followed by Java and .NET to implement the LangChain ecosystem. So stay tuned, see you in the next video. Hope you like this video. If you like the video, please press like and subscribe to the channel. Have a nice day.